Okay, Karabo, we are streaming to YouTube. We are ready to start when you're ready.
All right, perfect. Thank you.
Thank you.
All right. Hello, everyone. Welcome to yet another amazing lesson that we're going to have today for grade 6 natural science. I hope you all had a blessed and amazing Easter weekend and all with your family and just having a good time. All right, just to remind you, I am Karabo Khashane. I go by KB_Khashane on Instagram and Karabo Fiona Khashane on Facebook. All right, this is Natural Science Grade 6. And without wasting any more time, let's get straight into it. Let me just close this thing up. All right, there we go. So what I expect you to know by the end of this lesson is to know what the rate of dissolving means. So if you remember last week, we spoke about how we're going to talk about dissolving this time. So we are going to discuss dissolving and the rate of dissolving. We're also going to discuss about how does temperature affect the rate of dissolving of a substance. How does stirring affect the rate of dissolving of a substance? And how does the size of a solute grain affect the rate of dissolving? So it's 3 matters: stirring, temperature, and size. All right. All right, so let's just do a quick recap. So we basically just spoke about solutions last week and mixtures. And if you joined us, I'm sure that you can remember that topic very, very clearly. We tried mixing some water and sugar. We basically spoke about solutions. All right, so what exactly is a solution? A solution is a specific type of mixture where one substance is dissolved into another. A solution is the same or uniform. All right, so any type of mixture that we try and mix that actually gets dissolved into another would be called a solution. So examples of solution is that one example of a solution is salt and water, which is a mixture of water and salt. You cannot see the salt, and the salt and the water will stay a solution if it is left alone. So as soon as you mix salt inside the water, the salt immediately dissolves in the water. All right. All right, so let's get into it. Dissolving. Now, a solution is made when one substance called the solute dissolves into another substance called the solvent. So usually water is considered to be a solvent, and anything that we're trying to dissolve is called the solute. This could be sugar, this could be salt. Those are considered as solutes, and water is the solvent. Dissolving is when the solute breaks up from a larger crystal of molecules into much smaller groups or individual molecules. So if we've got grains of sugar, the moment we try and mix those grains of sugars into water, they actually become a lot smaller until we cannot see them anymore. So from a large molecule, it dissolves in the solvent, becoming a smaller molecule. It's still there, but we just cannot see it. Right, this breakup is caused by coming into contact with the solvent. So the reason the sugar is dissolving is because it's coming into contact with the solvent. Remember the solvent being the water. All right. Substances dissolve when mixed with water and will seem as if they have disappeared, all right? However, they are still there, but the particles are so small that you can no longer see them. So if you decide to go mix some sugar with some water now, you'll obviously see the sugar dissolving, but there will be a point where it'll seem as though the sugar has dissolved and it's no longer there, but it is there. It's just so small that we cannot see the particles anymore. All right. Now let's talk about the rate of dissolving. So how fast does dissolving actually happen? The rate of dissolving refers to how quickly a solute, this could be sugar or salt, dissolves in a solvent. A solvent could either be water. Now, the word rate has many meanings. In science, when we use the word rate, we usually mean how fast or how slow. For example, how fast is it that salt can dissolve in the water? Or how slow does brown sugar dissolve in water? All right, that is just an example of the rate of dissolving. All righty. Now, Tom likes his coffee sweet with 3 teaspoons of sugar. Now, for the coffee to taste sweet, the sugar must be dissolved. Now, here's a picture of a cup of coffee. Now, who remembers, for those who joined us previously, what do we call a solution that the solute does not fully dissolve? For example, we did the mixture with the sugar, and the sugar, some of the sugar did not dissolve, it stayed at the bottom. What do we call that solution? Who remembers? Just type in your chats, just to let me know, what do we call that solution that hasn't fully dissolved? Let's see if some of you remember, if you were part of that list. Maybe you just know. All right, Iksak, sorry if I didn't pronounce that correctly. Well done, it's called saturated. Excellent, thank you so much. All right, so of course, when it does not dissolve and there's still some sugar pieces and sugar crystals at the bottom or salt, it is actually called a saturated solution. Awesome, guys, well done. All right. All right, now I would like you to answer the questions about this cup of tea. In your chats, remember, just type in the answer. Is the cup of coffee a mixture? Give a reason. Is it a mixture? Let's see what you have in your chats for us. Is the cup of coffee a mixture? And give me a reason. In fact, if you want to actually give me the answer, you can raise up your hand and we will unmute you. You can explain to us why you're saying yes or no. All right, let's see, Tembeka. Tembeka, you said yes. Can you please tell us why? I'll just ask Melanie to unmute you. And you can tell me, why do you say the coffee is a mixture? Are you there, Tembeka, to answer for us? All right, doesn't seem like it. All right, yes, Kanya, how about you tell me? Why, what do you say? Is it a mixture, yes or no? And please tell me why, Kanya. Kanya, are you there? All right, so Kanya's saying yes, because it has coffee. All right, and Gadawa said it's mixed with coffee grains and water. All righty. All right, and Ted's saying yes, because everything is dissolved, and Lazi is saying yes. All right, all right. Those are your reasons, okay. What about this question then? Is the cup of coffee then a solution? Remember now, a mixture is if we can still see the grains. So can we still see the coffee grains and the sugar mixed together? All right, so now with the solution, would this cup of coffee be a solution? All right, Kanya saying no, Oletu saying no. All right, most of you are saying no, that this cup of coffee is not a solution. Right, yes, Tato, you raised your hand. What do you have to tell us today? Or do you have a question? Tato? Yeah. Tato, can you hear me? All right, let's move on. All right, well done for that, guys. So just to recap about that quickly. Oops, sorry, let's just go back. There we go. All right. So now with your cup of coffee, now mixture is if you can still see the different particles, if you can still see the raisins from the peanuts, all right? Now a solution is if the solute has completely dissolved inside the solvent, all right? Right, next slide. What are the factors of dissolving? The rate at which a substance dissolves can be affected by 3 factors. Now remember that. So you need to remember that for a solute to dissolve, it is affected by 3 factors. The first one is the temperature. So now if the water is cold, the solute will probably take longer to dissolve. Whereas if it is hot, it will probably be quicker to dissolve. Now it also is affected by whether or not the solution is stirred or shaken. If I'm going to stir my tea, the sugar will dissolve quicker. All right. And lastly, the grain size of the solute. Now, if you've got brown sugar crystals, which are a lot thicker, it's going to take a bit longer to dissolve. Whereas the white sugar crystals, because they're just a bit smaller, they're going to dissolve a whole lot quicker. All right. A solute will generally dissolve faster if the solvent in which it dissolves is warm. That's why you'll find that sugar dissolves a whole lot quicker inside warm or hot water. But if I had to put the sugar inside ice water, it's going to take a bit longer. All right. Now, a solute will dissolve faster when the solution is stirred or shaken. All right. So if I shake it or I stir it, it is going to dissolve a whole lot quicker. And lastly, a solute will dissolve faster if the size of its grains are small. I've given you the differences between brown sugar crystals and white sugar crystals. All right, now let's talk about dissolving versus melting. Who can actually tell me the difference? What is the difference between dissolving and melting? Right, you can either just type in your chat or raise up your hand. What is the difference between dissolving and melting? Right, Anirudh, I think I did not pronounce that correctly. Please forgive me. Do you mind telling us what's the difference between dissolving and melting?
So the difference between dissolving and melting is that the particles of the solute, so dissolving is when the particles of the solute spread evenly around the particles of the solvent. When you stir, like for example, if you take sugar and water.
All right, excellent. Yes, carry on.
And then melting is when it just becomes from a solid to a liquid. It's a process in which the particles gain more energy and then they turn into a liquid.
Ah, excellent answer. Thank you so, so much. What about you? There's no name though, it's P something something. I'm not sure who that is. You also raised up your hand. Yes, do you mind telling us what is the difference between dissolving and melting? What's the difference?
Is different to melting because when you melt, you use heat, and heat is an energy.
All right, excellent. Thank you so, so very much. Excellent answer. Thank you so much for that. All right, excellent stuff, guys. All right, so like I said, now melting involves a change of physical state. Now, Anirudh said that already. Thank you so much for that answer. Right, it involves a change of physical state of the substance from a solid into a liquid without the use of a solute or a solvent. So if I just put ice in the sun, it's going to change from being a solid into a liquid. All right. Now, in order to dissolve something, there needs to be 2 substances, a solute and a solvent. Whereas to melt something, you only need 1 substance. So now we know to dissolve, we need a solute and a solvent, but to melt, we don't need any other substance, just on its own. All right. Perfect. Let's move on. All right, let's look at these pictures over here. It says melting or dissolving. What do you know? Let's look at the first picture, hot water. So sugar into hot water. Is that melting or is that dissolving? In your chats, please tell me, melting or dissolving? All right, a lot of you are saying dissolving. That is perfect. So when sugar into hot water, it dissolves. Thank you so much, guys. Awesome. Right, let's look at the next picture on the right. Heating butter in a pan, melting or dissolving. All right, a lot of you are saying melting. Yes, that is definitely melting. All right. Thank you. Now let's look at the next one. Making jelly with hot water, melting or dissolving. Making jelly with hot water. Yes, it is dissolving. Very, very good. Jelly dissolves in hot water. All right. Who knows how to make jelly actually? Any of you know how to make jelly? Anyone? Yes, Tata says me. Awesome. I actually don't know how to make jelly. I'm still learning. All right. Great stuff. Thank you, guys. Right. What about the next one? Ice cube in a hot pan, melting or dissolving? Awesome. That is melting. Very good. A lot of you are saying melting. I love these answers that are coming in, guys. Thank you so much. You guys are amazing today. Hey, awesome stuff. Right. What about adding salt to a glass of water? Melting or dissolving? Yes, that is dissolving. Very, very good. Well done, guys. And the last one, chocolate going soft and runny, melting or dissolving? All right, yes, it is melting. Oh, you guys are amazing. So that is definitely chocolate going soft and runny is melting. All right, so you guys clearly understand the differences between melting and dissolving. Well done. All right. All right, let's try this activity now together. So we need to basically fill in the words. It's basically a crossword, which I have not attached, but we will just write the answers next to the relevant statement. Now, the first one says, at the top is your word box. And number one says, when a solute can dissolve in a solvent, we say it is 7 letters. What is the answer? When a solute can dissolve in a solvent, we say it is, as I wait for your answers, 7 letters. Muzi, soluble. Well done. We say it is a soluble. He was the first one to answer. Thank you, Muzi. And of course, Iksan, Faith, Razi, and it goes on and on and on. Well done. Thank you, guys. Next one. When we lower the temperature of the solvent, the rate of dissolving the solute will decrease. Iksan, yay! First one to answer. Well done. It will decrease. Then Arudri, Tedza, Skurudu, Tanze, Hanro. Thank you, guys. It will definitely decrease. Let's look at the next one. The substance that dissolves in the solvent is called the substance that dissolves. And we've got solute. Well done, Iksan. Again, the first one. It is called a solute. Lesedi solute, Karabo solute, Kanya. Well done, guys. Number 4. The mixture of the solute and the solvent is called the solution. Ashley, thank you so much. Hanro, Lwazi, Saad, and it goes Untadile. All right, well done, guys. It is called the solution. Number 5, when we cannot dissolve any more solute in a solution, we say the solution is saturated. Well done, Anirudh and Skudre and Tato. Excellent answers. All right, we say it is saturated. Right, now number 1 across. The substance that dissolves the solute is called the solvent. Well done, Iksan. It is called the solvent, and a lot of you are saying solvent. Well done. Thank you. Number 2, the solute in the solvent. Dissolves. Well done, Aruk. Tedza, Iksan, definitely, it dissolves. Right, and last but not least, when we want the solute to dissolve more quickly, we should stir. Thank you, Lizal, Handro, Untatile. We should definitely stir. All right, thank you guys for those answers. That was an amazing activity. You all did lovely. All right. All right, so what would I like you to take away for this lesson? Now, melting and dissolving is not the same. Now, you have all proved this with the previous activity that we did, identifying the difference between melting and dissolving. Now, dissolving happens at different rates depending on the size of the substance, the temperature, and whether you are stirring or not. All right, here are some helpful links for you. You can find this on YouTube. You can find some very helpful stuff on YouTube, that very specific link. Yes, Tabang, do you have a question?
But ma'am, I don't really understand, ma'am.
What is it that you don't understand, Tabang?
Ma'am, the first lesson, ma'am.
Sorry, say that again.
The first lesson, ma'am.
The first lesson, are you talking about maybe the first slide or which lesson?
Yes, ma'am.
Are you talking about the first slide?
Yes, ma'am.
The very, very first one that we did?
Yes, ma'am.
All right, let me see if I can go back. This one?
Yes, ma'am.
All right, so let me just go back to this one just to explain to you. Are you sure you're talking about this? This was just a recap. Would you like me to just explain the slide again?
Yes, ma'am. Please, ma'am.
All right, cool. So this was basically just a recap from our previous lessons, and we were just discussing the differences between solutions. Now, this slide basically talks about what a solution is exactly, right? Now, it says there that a solution is a specific type of mixture where one substance is dissolved into another. All right, so if I take sugar and water, what will happen, Tato, if I put 2 teaspoons of sugar inside the water? What's going to happen, Tato? If I put 2 teaspoons of sugar inside water, what is going to happen?
Ma'am, I don't know.
Sorry?
Ma'am, I don't know.
Okay, tell me what happens when you make some tea. How do you make tea? What happens?
Oh, okay. When you make tea, ma'am, you put the tea bag and hot water and some sugar and milk, ma'am.
All right, great. What happens to the sugar?
Ma'am, does it stay at the bottom?
Well, if you don't stir it enough, it'll probably, if you put too much, it'll stay at the bottom. But do you really think it stays at the bottom?
No, ma'am. Oh, sorry.
So what
Ma'am.
happens to the sugar?
Ma'am, the sugar's gonna be like, I don't know how to really explain it, ma'am.
Okay, so the sugar is basically going to dissolve. You're not going to see the sugar anymore, am I right?
Oh, okay, yes, ma'am, sorry.
All right, so Tasne and Karabo said dissolve. Very good. So when you mix sugar inside water, it is going to dissolve, all right? That's what's going to happen. All right, so that's what makes a solution. When we mix something that can dissolve inside water, it becomes a solution. Let's make an example. What about, do you drink Oros juice?
Not really, ma'am, but sometimes.
All right, so tell me, how do you make Oros juice?
Ma'am, you mix it with water. And
Mix what with water?
the orange with water, ma'am.
There
Then
you go,
you
you must say that. All right,
Yes.
so when you mix the Oros with the water and you mix, it's going to become a solution because I don't see the Oros juice anymore. All right.
Oh, yes, ma'am.
Solution. All right.
Yes, ma'am.
Awesome. All right, let's move on to my very, very last slide where I was. All right. Let's quickly move. All right, we did that already. All right, so I was just on the slide talking about helpful links. You can find a helpful video on YouTube. And next lesson, we're going to talk about mixtures and water resources. All right, that's going to be a very, very exciting lesson. So please, please do tune in. Remember, for more information, you can contact me on karabo.fkhashani@gmail.com. Or if you just have any more questions or confusions, please do not hesitate to just follow us on social media at Africa Team Geeks, at DBE_SA, hashtag Cecil Foundation, and also at Cecil SA, hashtag STEM Championships, and lastly, hashtag Lockdown eSchool. So for all your questions, queries, confusions, please, please, please do ask so that I can assist you. Thank you so much, guys, for tuning in, being so amazing. You guys have been super duper duper fantastic today. Have an awesome day and see you again tomorrow. Goodbye, guys.